This is a continuation of homework set 2, properties of real numbers, but now we're going to look at questions 9 through 15. Let's use the distributive property to rewrite this expression here. So I'm going to distribute this 12 to the 1/4 x, and then I'll distribute it to the 1/3 y. So let's do that. I'm going to write this as 12 times 1/4 x plus 12 times 1/3 y, and then 12 times the 4th. Now you can do that like this. Just multiply tops together. 12 times 1 is 12. 12 divided by 4 is 3. Or you can think of it this way. What is 1/4 of 12? Right? Order doesn't matter here in multiplication. Think of it. What is 1/4 of times 12? 1/4 of 12 is 3. But you still have the x, so don't forget that x. So that'll be 3x plus, and then over here, we've got 12 times a third, so think of it two ways. 12 times 1 is 12. 12 divided by 3 is 4. Or if you like, what is 1/3 of 12? It's 4. So 4y. Now what I've got here are 3 x's and 4 y's. These are different things. I can't add them together. What would I get? 7 what? So I'm done here. So I'm going to get 3 x's plus 4 y's. In problem 10, we are again going to use the distributive property to rewrite this expression. Now look at this. We've got a multiplication, right? 3 times that 4a minus 4. And then we're going to add 2. So what are the operations? I've got a multiplication, and then, right, I'm multiplying the 3 and this. Now the parentheses indicates that this 4a minus 4 is just one single unit. It's just something with a longer name. So I've got 3 times the 4a minus 4. Then I'm going to add 2. So I've got a multiplication and an addition. So by the order of operations, I'll do the multiplication first. So that will look like this. 3 times, okay, I'm just going to rewrite this. 4a minus 4 and then plus 2. So let's do this multiplication first. So I'll get 3 times the 4a minus 3 times the 4. And then I've got that plus 2 out there. So let's go through this one left to right. Now what have we got here? We've got a multiplication, right? There's no dot, but when you have a number and a variable next to each other, it indicates a multiplication. So multiplication, multiplication, subtraction, multiplication, addition. Let's do this multiplication and this multiplication before we do the subtraction and addition. So this will give us 12a, then minus 3 times 4 is another 12, plus 2. Now I have a subtraction here, but I can't really subtract 12 from a 12a. But I'm going to think of it this way. I'm going to have that 12a, and then what is this? I'm going to think of it this way here. I'm going to think of this as negative 12 plus 2. So I'll just think of it. It's not really negative 12. It's minus positive 12. But I'm going to think of it as negative 12 plus 2, which is negative 10, right? If I'm down 12 and I add 2, now I'm only down 10. Now, I stretched everything out here. What you could do, of course, is just look at this and see. I don't need to write all this or all this. Just do this. 3 times 4a, 12a, minus 3 times 4, 12, plus 2. And then negative 12 plus 2. Maybe 2 steps, maybe this step and then this step. In question 11, I'm just going to leave all those instructions off. We know what we're supposed to do. We're just supposed to simplify this expression or rewrite it. So what have we got here? We've got an addition, and then in parentheses, this is all one unit. So I have this unit times 2. So I see a multiplication and an addition. So I'm going to do the multiplication first. So distribute. I'm going to take that 2 in here, and then minus, and then multiply it in here. So I'm going to bring that first 3 down. It's that one right there. And then plus. Now multiply. What is this one here? What is the 2 times the 3? I'll go ahead. Well, let's just do it. 3 times 2. We know what that is. I'm just going to write it. 3 times 2 is 6. Minus. Now just do this one. 3x times 2. 3 times 2 is 6, so I'll get 6x. Right, so I'm going to have the 3 plus 3 times 2 is 6 minus 3x times 2 is 6x. Now, just go left to right. What have we got? An addition, subtraction, multiplication. I can add these two together. That'll give us a 9, right there. 9 and then minus 6x. I can't combine those. The first one's a 9. I can't subtract 6 x's. If it was just 9 minus 6, I could do it, but not 9 minus 6 of something else. Question 12, let's use the distributive property to eliminate that set of parentheses, and then we'll add 7x. So let's multiply through here, 4 times 4x, and then plus 4 times 5. So let's do this one here. What is 4 times 4x? 4 times 4, that's 16 x's, and then plus, now over here, we've got 4 times 5. Let's just do it. 4 times 5, you can do that. That's 20. Well, let's see if I can write it. 20. And then plus 7x. Now, just look at this thing left to right. What have you got? You got 16 x's. You're going to add 20. Then you're going to add 7 more x's. So how about if I just think of it this way? I've got 16 x's, and eventually I'm going to add 7 x's. So I've got 16 x's and 7 x's. That is 23 x's. Oh, let me keep it in white here. So I'll have 23 x's, and then I still have that plus 20 out there. And those don't combine. I've got 23 of something, and then I'm going to add 20 to that. So 23x plus 20. Question 13 is a little bit different here. We're not going to simplify anything. We just want to look at which property with real numbers justifies this. Okay, we've got 2 plus 0 equals 2. Now, is one of these properties, is it the multiplicative identity? No, the multiplicative identity says something like this. If you multiply 2 times 1, you get 2. All right, that's the multiplicative identity. Is it distribute? Did we distribute anything here? No. Did we add anything? Well, I'm adding 0. Additive inverses. Additive inverses mean something like this. What if I had 2 plus the inverse? Okay, that would give me a 0. That's not what we're doing. It's not the commutative property. That would be like if I had 2 plus 0 equals 0 plus 2. It's not the associative. That would be like, say, well, I'm not going to do that one. The multiplicative inverse. I'm not really multiplying anything like this. Let's look at this one here again. Additive identity. Now, the additive identity, that's 2 plus 0. 2 plus 0. I'm adding something that gives me that 2 back. So that additive identity, 0 is the additive identity. Because when you add it to something, it retains the identity of that something. So this is the additive identity. Okay, it looks like a little bit of work here in question 14, but what we're supposed to do is just match the definition with their property. All right, so what is this one? You have A plus B, and then you just switch the order. All right, when you switch the order in an addition, when you switch the order, it's called commutativity, or the commutative property. And I'm adding. So let's see. I think we have a commutative property of addition. So which one do we see over here? Oh, it's the first one here, right? So this is an A. All right, so that would be, all right, I think what you're supposed to do on the computer is call that one A, but I'll just write it in here. This matches with A. Now, what about this one? Well, this is a multiplication, right? A times B, B times A. That's a commutative property of multiplication. So do we see that one over here? Look for commutative. Here it is. Commutative property of multiplication. So that's a D. So I'm going to indicate that one as a D. Now what about this one? I got A plus B plus C. And then it looks like the parentheses have been reassociated over here. A plus B. So this is an associative. I reassociate parentheses. So that's the associative property, and it's all addition. Do we see that? Here's associative property, but that's multiplication. Here's associative property of addition. All right, so that's a G. All right, so this is going to be a G. The next one, what do we have? All right, I've got A and then BC and then the AB. The parentheses have been reassociated. So this is another associative property, but it's involving multiplication. So associative property of multiplication. Do we see it? There's associative multiplication. That's what it is. This is B. So this is going to be a B here. And then, what about this? Okay, I've got A times B plus C, and then I got AB plus AC, right? AB plus AC. This is just the distributed property. Now, do we see any distributed properties here? There it is, down there at the bottom, I. All right, so this is going to be an I. Now, what's next? Okay, A plus 0 equals A, and 0 plus A equals A. So I'm adding 0 to some number A, and I'm getting A back. So I'm not changing the identity, and it's addition. So this is called the additive identity. So do we see one over here? There it is, H, additive identity property. So this one here is an H. A times 1 equals A. 1 times A is equal to A. So I'm multiplying A by some number. I'm getting A back. So I'm retaining the identity. So this is the identity property of multiplication. So this is the identity property of multiplication, or the multiplicative identity. All right, so do we see that over here? That's the additive identity. Here it is, F, multiplicative identity property. So this one's going to be F. And this one, A plus negative A, gives us 0. All right, so I add two numbers together, and I get 0, but these numbers are opposites, right? A and the opposite of A. So these numbers, A and negative A, they're opposites, or they're inverses of each other. Inverse, opposite. So it's an addition. So do we have an identity of with addition or inverse? Here it is, additive inverse. Additive inverse property. I'm adding the inverse of A. So that's going to be, what was it? It was C. All right, so this is a C, and there's only one left, but let's just check it out. Now this last one, there's only one left, but let's figure it out here. We've got A times 1 over A, and we're getting back to 1. This is 0, is called the additive identity. This is the multiplicative identity. So if I take a number, multiply it by its reciprocal, I'll get back to 1. So this is called a multiplicative identity. So do we see one of those over here? Just work our way up to the list for multiplicative. Here it is, multiplicative identity property. It's F, and let me just run a quick check. We have not used F, so I think I'm going to label this one as F. And the last problem, number 15, says use all these properties, commutative, associative, and distributive property, to simplify this expression, or just rewrite it. Now let's look at what we have here. I've got a 5, and I'm going to add one of these 4x plus 6y's. Now that number out here is assumed to be a 1. So I just have one of these. Whereas over here, do you see how many of these 7x plus 6's there are? There are 6 of them. So there's no 1 out here. We just don't write 1. So here's what I've got. I've got 5 plus one of these, 4x plus 6y. I don't really need those parentheses. If there's a set of parentheses preceded by 1 or no sign at all, it's assumed to be a 1, you can just remove the parentheses. But then over here, I'm going to add, right, there's the addition. Now let's multiply in here. Let's just do this. What do you get when you multiply in? 6 times 7x. Well, 6 times 7x, that is 42x, right? 6 times 7 is 42. You still have the x's. And then over here, plus, let's write that plus. And then we'll have, all right, what have we got here? We have 6 times 6. That's a 36. So I'm going to go ahead and write that, 36. All right, now let's add up I like to do the variables first. So look at all the x's. Look left to right, and see if you have x's, and we'll combine those. Now here's what I see. I see 4 x's, and then I see 42 more x's. So I'm seeing these, 4 x's and 42 x's. So let's write that. 4 of them and 42 more is 46 x's. I'm going to leave a little space here. So I'm going to have 46 x's. Then what? Look at the y's. Okay, I've got 6 y's here. Oh, that's it. No more y's. As I look left to right, no more y's. So I'm just going to write now, I've got 6 y's. And what else? What about just constants? I got that 5, and then over here, I've got a 36. So 5 and 36 is a 41. Okay, that's it. So this tells me that this expression up here is equivalent to, and in simplified form, is what? We're saying we've got 46 x's. To that, we're going to add 6 y's, and then to that, we're going to add 41.